And good morning. Good morning to all of you. Let me know if you can hear me, if everything works. First of all, I will check it too, because in the previous video the audio wasn't working at all. And let me know if it works. Let me see. It's not this one. It is this live one here. Okay, it should be perfect. Oh, excellent. Everything is fine. So, we are ready to start this beautiful lesson where we have to explain a lot of beautiful things there are. Today we need to talk about lights. And we will see today, let's see if I can. Good morning. In the meantime, let me write our today menu. That will be, we need to see how to work with free lights. Later on, I will explain the very simple difference between free light and target light. Nothing complex, nothing crazy. We need also to discover something unbelievable, that is, after explaining how to work with these lights, that would be for today, it would be basically start understanding how to simulate artificial light source. We will see also how to use an interesting parameter of material that is called emission. But this at the very end. And this is a parameter of a material that I need to explain after explaining lights, because if there are no lights into the project, this parameter simply won't work. So this is very basic. Lights won't be just these. Next week we have to make a second part of lights, because for lights then we need also to explain, but not today because it would be too much stuff. We have to discover how to simulate sunlight, and then we have to explain a more generic concept that is a photography concept that is called exposure. Okay? But this will be next week. And also next week, because these are not two elements that will require 2 hours of a class, next week I will also explain how to import 3D blocks in your project. But lights are a bit more important, so let's start. As usual also, before I explain anything new, do you have any quick question for me or not? Or you are good and we can start? Let me know. Let's see. Let's see. Just let me know if you have a quick, super fast question or not. Perfect. Loving to this, man. I'm addicted. I'm addicted. Thanks. I appreciate it. Honestly, if you just want to know, believe it or not, a lot of people find relaxing doing things like reading books, for example. There is something that I personally don't do. I don't really like to read books. I'm stronger than me. Believe it or not, when I want to really relax, you know what I do? I open 3ds Max and I start using it, and I really, not only I like it, I find it really relaxing in creating things, materials, lights, modeling, and stuff like that. So I can understand why Amy says can't stop. I mean, I'm in this situation too. If not, probably I won't be here too. Anyway, let's see what we have to do to start working with lights, because if I just use lights in 3ds Max, let me tell you that these will be barely useful, because when we create lights, we need to see the effect of lights on geometries that we have created in our project. So before adding a light in my project, I will simply create a very simple room that just has more or less realistic dimensions, so not too big, not too small, nothing crazy. But I will create a room. I mean, this can be higher. Perfect. Stuff like that. I will put something into the room as well. Okay. And I will move this thing up. Yeah, just a little. small boxes, but nothing fancy. Okay, this here. Okay. I have this empty room. Before using lights, I want to make one small adjustment to my room just to better understanding what we are going to see next. That would be behavior of light. That is, I need to make my room white. Because for example, a parameter that we are going to see in a while will be the color of light. So if I make the color of light white or yellow or green and so on and so on. But because my objects right now, they are already blue, maybe this will be a little bit confusing, because if my walls are blue, but I make my light yellow, then I will see walls becoming green and so on and so on. So no. I will simply make my own, and this will take 1 second. I will make a material, like we've seen last week, and I will double click it so that I can make it white, so it will be 100% neutral. Okay? And I will simply apply this material to all of my objects, so that they are for sure all white. Perfect. And this is first simple step that I have to do in order to have a better understanding of light behavior. Not because all of your projects must be white, but simply because I want to understand if I change the light red, walls become red, and so on and so on. So, what are lights? In 3ds Max, lights are nothing else than objects that you can create. So, when I want to make a light, I just need to go on Create tab up here, and I can see that after Shapes, there is that symbol with a bulb lamp, that is light. In here, I will find these 3 buttons called Target Light, Free Light, and Sun Positioner. As I said at the beginning, we will start viewing free light, and today I will show you also when you should use target light. Sun Positioner instead is to simulate physically correct behavior of the sunlight. So we will see it next week. I will use free light first, and to make this happening, I have just to click it, and I will make my light just by left clicking once, and I will place it somewhere. I will place it here. Look, just outside my room. Okay? There is one small interesting aspect of working with lights now that I want to show you. That is this. If I use lights, I would like to see in real time what light makes in my project. Right now, if you try to move your light, nothing is visible in your viewport. So I want to change 2 small parameters in your viewport to let you see in real time how light works without rendering time, without needing to press rendering here each time that you adjust a light. Okay? So, let's see how you should set your viewport to correctly work with lights. Look, what you have to do is this. You have to click here where you see standard, okay? And in here you have to go to the menu called lighting and shadows, and then you need to select the option that is called illuminate with scene lights. So you must click here. Ready? 3, 2, 1, go! Boom! And you will see that by making these small adjustments, now if I move my light, I can see in real time my scene being illuminated by this light. But this is not enough, because there is one more thing that I need to do. So I will go again to the previous menu that I showed you. So I click here, I go to lighting and shadows, and there is one extremely important parameter that I need to check. That is the one that is called shadows. So I need also to check this one. And now, not only my scene, give it a second, exactly, my scene is illuminated by my lamp, but also shadows projected by this light are immediately visible in real time inside my project. Okay? So, just to show you again, your viewport should be set like this. Go to, now it is called user defined because we have changed custom parameters, but in the menu that is called lighting and shadows, you must have this set up, so where these two options are both enabled, the one that is called illuminate with scene lights and the one that is called shadows. Boom! From now, whenever I will place a light in this project, and remember, this adjustment must be done file by file, so it's not a 3ds Max parameter, it's a file parameter. So when I open a new one, I will need to set it again. But look at that. I can clearly see, according to where my light is, how bright each wall becomes, which kind of shadows I project, and so on and so on. Okay? So now, if this works, let me check the chat. Perfect. So, if you can all do this simple thing, that is, you can correctly set your viewport like that, we are ready to see which are main parameters of a light that we need to control in order to simulate the light that we want for our project. Parameters are all listed into the Modify tab, of course, and we have to deal with these parameters that I will write just to have an idea of what we are going to see. First of all, we need simply to check shadows. Sometimes, for no reason, they are not checked, but I will show you what to do with shadows. We have to see a very important parameter of light that is called distribution. That is basically the direction that light has from our light source. Then we have to see the color of light, a very basic parameter. Then we have to see another simple parameter called intensity. of light, so basically how bright light will be. And last but not least, and this will be a little bit tricky, we need to see a parameter of light that is called shape. So let's start from first, and they are also listed in this way into the Modify tab. So let's start from first one, the one that is shadows. Look, when I select my light and I go to the Modify tab, first useful parameter is the one that is called shadows. What you need to do is you have to simply check how this parameter is set, and in any case your shadows must be exactly as you see them in this particular moment. That is, shadows must be always on, first of all, because it doesn't exist a light that doesn't also cast shadows. And also, this parameter must be ray traced shadows. That is the algorithm that is used in order to create shadows that takes informations of the shape of my object and also on informations of the material. So my material is opaque right now, so the shadow is black, is dark. But if my material was transparent, due to this parameter here, my shadows will be also transparent. So shadows must be like this. In here, there is nothing to invent, nothing to create, nothing to imagine, but this is how shadows are simulated in order to in order to simulate realistic light behavior. Okay? This is first simple parameter. Nothing fancy, but it has to be like this, because if not, your renderings will be unbelievably fake looking. Second parameter instead, the one that is called light distribution, starts by being more interesting. And here we have to discover at least 3 different options. If I see, by default, whenever I create a new light distribution is always set as uniform spherical. What this does is basically, it simply sets that if here I have my light direction goes all over the space, so it goes down, it goes up, goes in front, goes back, goes right, left, like a sphere of light. And this happens in all directions. Okay? So you can see that this wall is receiving light, this floor is receiving light, as well as this. And if we change our point of view, we will see that also the ceiling is, look, if I zoom out, even the ceiling is receiving light. This is due to the distribution, so the direction that light has, and by using the parameter called uniform spherical. This is fine, not all the times, but when we want to simulate a light that is, believe it or not, a tube lamp or a bulb lamp, in both cases we need to use uniform spherical distribution. But just in these two cases here. And if we want to make another kind of light, we need to change this parameter to have a completely different simulation. For example, if I want to simulate an LED light, so LED is something that is like this. It has a support. So the LED light is not going all around the space. It is slightly directional, but it is also very wide. So the LED light in general has a distribution that is like this. It is very wide, but it doesn't go in all direction because the LED has a support where it is mounted. There can be a piece of plastic, it can be like an LED strip, stuff like that. So this particular distribution, there is like half sphere of light. This is called uniform diffuse. And we can change this parameter by simply selecting uniform diffuse from the menu that is called distribution. So instead of spherical, I change it to uniform diffuse and see how it will change my light. This will be like half sphere of light. And if I want instead to change where this light is projected, what I have to do is simply I have or move my light or using rotate to rotate this orientation. Okay? But this is basically, so you can quickly remember that uniform diffuse must be used when you want to simulate LED lights. Okay? Last but not least case is when I want instead a more directional light source. So a light source that is in general called a spotlight, that more or less is like a cone of light. So last interesting option that I should learn from distribution type is I can change my light to spotlight, and light direction really becomes a cone. So where I have my light is basically the vertex of my cone, and the light will have, oops, a little bit too thick, but it's okay. Sorry, it's a little bit too thick. So the light has shape of a cone, but you will see that the cone is something that we can manage. So we can change if we want a cone that is narrower or a cone that is wider. Also, the cone of light that is created by a spotlight has an area that is this one, that is where lights starts fading from light to darkness. And this shape basically, so both the angle of this and the angle of this inner cone, they can be both change it as we like, simply because only when we select light distribution as spotlight, only in this particular case, this additional menu will pop up. In this menu, there are two values. One is called hotspot. There is this one. And hotspot is how big this cone will be, and it is in degrees. So if I measure this angle, this is right now 30 degrees. Second number is called fall off, and again it is in decimal degrees. But this is how this secondary cone is wide, and again this is, let's say right now, 60 degrees. So if I want a narrower or a larger, on a spotlight with sharp edges or a faded edges, what I have to do is I have to play with these two numbers that will change like this. The hotspot changes inner part of my spotlight, so the one where there is a lot more light. Fall off changes the area that will make my light fading. When they are basically the same, there is like a sharp step from light to darkness, but if I want, I can make my fall off becoming very wide, and I can have this very wide area where light fades from brightness to darkness. Okay? And again, these numbers are appearing only because into the previous parameter, the one that is called light distribution, I have set spotlight. When I use uniform diffuse or uniform spherical, there are no additional parameters to be changed in order to set the direction of light. Okay? Till here? Is there also a way we will see this later on. We will see this later on because in order to make like a more ambient light, like you said, a ceiling light, it is a combination of factors. That is, we must use always a light source, but we can also use it in combination with a material that, as I said at the beginning, a material that has emission. So a material that looks like it glows, and it gives like a halo of light. Okay? So it is more complex than just picking one light. It is something that is more articulated. But let's see an interesting thing. That is this. Second parameter, this is third parameter that I need to show you is color of light. So the color of light, which one is perfect for outdoor garden lighting ale? Look, in 3ds Max there is how can I explain? You have not to think like which light I should use to make an effect. You need to make a very straightforward process. That is, if I buy a certain lamp for my garden, which kind of light, which kind of real light is inside that particular object? So there is nothing to imagine, nothing to create for only for 3ds Max. You really must use realistic lights according to the realistic product. So look, if you, and this is something that I will show you later, but if you go to like garden lamp and you have this, for example, just to make an example. In here, there is nothing to imagine. This is a bulb lamp, so if you want to simulate this particular light, you must use spherical, uniform spherical, for sure. But if you see, let's say, in here, these maybe are several LED lights, so you can see that here there is this kind of glowing thing, and light is going on the side rather than down. So in here maybe you should use something like having more lights and using uniform diffuse and having lights oriented in back and forth, left and right directions, but not up and down. In here instead, look, these are clearly spotlights because they are pointing down. Or like this is a spotlight that is pointing down. Even here, this is even more clear as a spotlight. Okay, so these are bulb lamps again. And what you have to do is you have really to use the light that is in the product that you want, and you have also to build the entire shape all around the light. Let me show you this first. Let's say I make it uniform spherical, okay? And this is why, because I've seen this thing here. So look, I have this kind of shape, but then there is a bulb lamp inside. So in here I have not to think like which will be the one that will work better. No, it is a bulb lamp, uniform spherical, but I have to build this object here. So check this. I will quickly make, so don't mind if I go fast, but it's just to make that shape. I make a cylinder, I apply edit poly, select all these objects, all these vertices, and I scale them first. Perfect. Just to give me that kind of look. Fantastic. Then there is something on top of that lamp. To me it looks like a box that has 3, 3, 3, like this. I move this thing up, and again I apply edit poly just to bring these polygons like that, and then these edges a little bit up. Perfect. Fantastic, I would say. I have almost done. There are also those elements, there are lines. Let's see if I can quickly make it from here to here. from here. I'm just using snaps. Snap to the vertex. Perfect. I mean, it is a simplified version, but I just want to show you. And then I have to make them renderable. I know it is not as pretty as the original picture, but it gives you the idea. Okay. And I will finish with this line here. Great. So let's say this is my light fixture. I will make this a little bit bigger. Okay. Fantastic. I mean, it is even better than the original. I will make it as a group. So at the end, in 3ds Max, I have this is my light fixture, let's say the garden one. But inside there is a bulb, so I will place these where it is in reality, so it is here. And then it is underneath this dome. So this is how, oops, it is not in the center exactly. Now this is into the center. This is how my light will work if I select that particular product. So it is a combination of using light distribution and light fixture. So you can easily add multiple. Of course you can add in your project. You need to add as many lights as there are in reality. What it means? Let's say again the example. In this garden, there are 3 of these things. You will make 3 lights with 3 light fixtures and so on and so on. In here, there are all of these. There are, boom, you will place them all. So in a space, you need to place as many lights, as many lamps there are in reality. Another example. Look. Let's say this light is here. If I have more lights in my project, and for example, I will make this again as a spotlight. Okay. That is, let's say, the one close to the ceiling. Perfect. But if I want another of these lights, so if all around my room I have rows of spotlights, like I can move one light, I can even shift and... Oh, there is a mosquito. No. So what I can do is I can shift and move this light, so that even if this is a light, it is just an object in 3ds Max, and I can make instances, I can make copies, so I can start placing as many lights that I need to have light setup that I have in reality. I can have 4 lights that are all instances on the right side, but as well as these, I can have shift and move, and I can place, but let's say we'll make copy, and you will discover why in a second. So I have as many lights that I need. Okay? They can be instances, they can be copies. Again, if I make instance like any other object in 3ds Max, they will always have same parameters. So, if I change these, for example, you will see that all my instances will change together, while my copies are not, but they will act independently because they were copies. They are similar because they are a group of copies, so they work together, but they don't follow these. Okay, so you can create as many settings that you want by using even for lights copies or instance. And I have made this example not only to answer the question of your classmate, but also because my next parameter is something that becomes very interesting if used in combination with copies or instance, that is the color of light. So next to the distribution, or to be precise, below distribution, there is the color. Color can be changed in several ways, but there are two ways that are highly efficient in changing the color. One way is very free. It basically allows you to give the light whatever color you want, and it is by simply clicking on this big rectangle that you find inside color. So this is color, and if you click inside this bigger rectangle, what happens is that you can give your light whatever RGB color that you want. So you can really change RGB values, and you can have whatever color you have in mind. Okay? You can change it from here, you can pick it from here, you can change instead hue, saturation, and here is called value, should be light. So you can make it brighter, more saturated, you can change the hue. Okay? And in this way you can have whatever free color into the RGB spectrum. And this is this happens a lot of times, for example, with all LED, with most of LED lights. There are also RGB LEDs, okay? And you can give this light whatever kind of color you want. And they will also, of course, paint the reality that is all around these lights. So my walls now are looking blue, not because I'm changing the material, but because I'm projecting blue light on top of my walls. For example, I can make a very nice experiment. There is this, look. I can have, look, 3 spotlights. This would be unbelievable, but look, if I have 3 spotlights and I make them as 3 copies so that I can change their colors, so 1, 2 and 3, I will slightly change the orientation of these so that they all point on top of my table. But then, see what I will do. I will make the color of my spotlight I will make it red. The color of my second spotlight, I will make it green. So green is here. And third one, I will make it blue. That is here. Or I can exactly quickly type 0, 0 to 55. See what happens. Look, in my project, I don't even have one white light, but I have RGB color, so I have a red, green and blue light. When they are all working together, so where all these three lights are projected together, the sum of basically the combination of these three colors is becoming white, while when I have only blue light, my light is blue. Where I have only green light or red light, when I have combination of two of these, like red plus green light becomes yellowish, red plus blue light becomes purple, and so on and so on. And I can start combining these lights to create whatever kind of realistic effect I want for my project. Okay? But if in here, let's say, I have a white teapot, then I will put on top of the table, exactly, and I will also, this is bluish right now, but I will apply my white material. Look, the top of the teapot, that is the one that is hit by all the three lights, is white. In here, my blue light is hidden, so it receives only green and red, and it is yellow. In here, it receives only the blue and the green, so it is teal, and so on and so on, and I have this phenomenal realistic effect by using color of lights. Okay? Fantastic, isn't it? And sometimes, by the way, so this is just very interesting and we can make very cool things. But if we make our color filter back to white, I want to show you instead a more technical way to change, to correctly manage the color of light. So sometimes instead of having just cool looking things, we want to be more precise, and let's say we want to tell our client that we are using a certain lamp. So when we read lamp specifications, we can find one first parameter that is called color temperature. And in some, let's say, cheap light, it is just called like warm white or cool white. But if you read technical lights, you can also find that sometimes it is even explained the number that is the color temperature. There is a number written in Kelvin degrees. Kelvin degrees is a way to describe color of light in this way. That is, Kelvin degrees is a value that goes from, mosquito, I hate it. It is a value that goes from 1000 to 20,000, And at 1000 our light is red. The more we increase this value, so the more we go higher, the more the color will drift from red to orange to yellow to white. But after a certain value, it will go to blue. Okay? And you can do this by checking Kelvin degrees parameter in your 3ds Max, and then you will see that if you decrease this value, your light will become super red, but the more you increase it, the more you will see this transition. Look, it goes from red to orange to yellow to milky white. At 6,500K, this would be pure white. But if you go more than this, then the light will turn blue. Okay? This is an information that if you go to websites or even if you buy a lamp, look here. If I go to a website like Philips and I want, let's say, to simulate this light, I have all parameters that I need that are written here, and I can see that parameter number 1, the distribution, this is called a spotlight. So this will be like a cone of light. Then I have another parameter that is, as I was explaining, the color, not this one. This is another thing. But I have the color temperature, and I can read that this is 4000 K. So it is called cool white. That means it's slightly yellowish. And if I want to test it, I go to 3ds Max. I set Kelvin, double click, type 4000. This is the exact color that light will give me. So it is not pure white. For example, it is slightly yellowish. Okay? Or if I buy another lamp, let's choose another. Let's say this one. Again, this should be a spotlight. For example, this is 2700K. So it is also called warm white. So it gives you this kind of warmer tone. And if you check, I type 2700, boom! And this is real color that light will provide. So very, very orange. Okay? Till here? Let me know. Does it work for all? Tell me something. Perfect. So, let's see. Great. So, let's see another interesting thing. That is, if we spend another second, look on that page. we can see another interesting parameter that is called here. It sounds ugly. It's called the nominal luminous flux here. But imagine that instead of this complex thing in here, imagine if it was written intensity. Wait, it has to be intensity. So intensity. Intensity is basically a parameter that simply says how bright our light is. So it is a value that has also certain units, and according to the brand we can find 3 different options. In here we can see that after the number it is written LM. There is a photometric unit that is called lumens. Lumens. Okay? In 3ds Max, again, there is a parameter called intensity of light, and according to the fact that certain brands use different units, when you go to intensity, you don't find only this number written here, but according to informations that you have the possibility to choose between LM unit, that is lumens. So let me write them. LM is lumens, or in some situations you can find that your light is described into candles. Candles is CD. Or, again, sometimes you can find a certain light where intensity is described with a unit that is called lux at 1 meter. LX at, it is lux at, and in general it is like 1 meter. Okay? But doesn't matter which parameter you set here, because this is something that simply allows you to correctly read parameters from existing lights. What is really important is that intensity works by simply understanding that the higher the number is displayed, the brighter my light will be. So, beside the units, you simply need to understand that if you want a stronger, brighter light, you have to increase this value. Or if you want a darker, light with a more subtle effect, you have to decrease this parameter. Okay? What you have just to know is that this parameter is called a logarithmic parameter, is not a linear parameter. So what it means is that values of intensity are going like this. And what it means is that at the very beginning and after a certain amount of number, the value looks like it is not changing, or it quickly change instead. So if you just do this, at the very beginning, small clicks makes a lot of difference. But after a while, look, if I keep clicking, it looks like nothing is changing because I'm here in the curve. So light changes in a logarithmic way. It means that if I want a very bright one, I have to left click and drag this parameter a lot. Okay? But when I go up here in the curve, look, even if I change, if I keep increasing, light is burning and that's it. And it won't change anything after a certain value. So just to show you how you should manage these numbers. So don't try to make this click, 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 because if not, it will pass 1 year and you will still be here. Try to change this parameter. Okay? So you have to left click and drag down or up to see changes into the intensity of light. Okay? Also helpful for what we learned in Verzad class. Oh my gosh, that is fantastic. I mean, it looks like we know what we're doing. Very nice. But yes, you know what? In 3ds Max, believe it or not, because light is managed with real photometric units, you can how can I say? You can develop exactly something that in general is called lightning design. So you can really understand the simulation of which light you want to use, how many lights, where lights are placed, which color of light you want to use. You can really make a simulation, and if you also use realistic datas like these that I'm showing you, no? Like you go to Philips, even IKEA website shows you the color temperature, the flux, and so on and so on. But for example, let me see what is written here. There is the efficiency, there is also the this is the power consumption, so how much electricity it will work each hour that this lamp is turned on. So for example, you can say that my light, and also look, it is also written in candles and in lumens here. That's very technical. But you can start saying, okay, if I use 3 of these lights, they will make a certain light, a certain effect with a certain color, and each hour they will consume 9 watts total. So you can really make a realistic kind of illumination project for your exams in general. Okay? That is extremely interesting and, let me tell you, highly professional for an interior design. So, till here, let me tell you, nothing really complex. So the intensity is simple, the color is simple, distribution simple as well. Now I want to show you something that may be a little bit tricky, but extremely realistic. That is this. Look, I just make these white again, and a little bit stronger. Fantastic. Okay, so let's see this, and a little bit wider. Okay, so look now at the shadow. So first of all, let me show you which is the problem that I want to solve, and we will see in a second how we are going to solve it. So my problem is that if I look at the shadow of my table projected on the floor, it looks a little bit too precise. This is the shadow of my table. And, for example, this is how the shadow looks like if you draw this, you know, like in perspective by projecting these points with the pencil and the ruler. But this is a little bit too fake. It is good for a geometry homework, but not for a realistic purpose. Because in reality there is another interesting parameter that affects light behavior. That is the shape of light. And even more interesting than the shape, it is the size. Because in reality, and not only in 3ds Max, so because 3ds Max then will simulate this behavior of light, but in reality it happens this. If a light source is very small, like a dot, let's say, like a point, a small light source will create, exactly like it happening now, it will create extremely sharp and black shadows. This is what happens if light source is small. But also in reality, oh, wait, let me see the chat. Okay, let's imagine I haven't seen this message. Anyway, I was saying, in reality, it happens that the bigger the light becomes, the more blurred and realistic shadows will be. And if you want, you can make a test by yourself. There is this. You can try by doing this. If you use your smartphone light, that in general is a very tiny LED, and you try to project your hand shadow on a table, you will see that because the LED of your smartphone is very small, the shadow of your hand will be let's make it black. It will be black and sharp, perfectly visible. But if you basically do something like very simple, you put a tissue or a white fabric in front of the light so that the light becomes bigger, and it becomes as big as the entire white sheets. What happens is that light source becomes bigger, and in general is said also more diffuse, and the shadow of your hand will be completely blurred. This is a behavior of light that not only happens in reality, but it can be simulated inside 3ds Max. By doing if you want to do this, you have to select your light, and after setting the intensity, the distribution, the color, and whatever, you have to scroll down a little bit the menu where you see shape of light, and you can see that my shadows are so sharp because by default light shape is always starting as a point, so it is infinitely small. But for example, if I change my spotlight from point to a bigger shape, like a rectangle, you will see that shadows projected from this spotlight will be softer. And when I change my light shape from point to another one, not only I change the shape, but I can also change the size. So, for example, you can see them, but I have two lights that are pointing at me right now, and they are square light. They are lights that are 60 by 60. They are spotlights, but they are creating soft shadows. Okay? And I can test that their shadows are really like this. There is only one interesting aspect of shape of light in 3ds Max, is that it is not always possible to obtain all combinations between light shape and light distribution. There are some combinations that work, there are some combinations that are impossible to make. So just to have a reference, I will write them here. So just remember, in 3ds Max, if you use uniform spherical distribution, so let's make a chart. On top we have this distribution. Down you have shape. So with uniform spherical, it is going to work only sphere of light or cylinder of light, because you can make tube lamps as well. These combinations will work. But if you use uniform diffuse or spotlight, you can only use shapes that are rectangle or disc. These combinations will work. Any other combination is not going to work. So if you try to make a spherical shape that has a spotlight distribution, it doesn't work. And not because I say like this, but you can try by yourself. Look, if I change this, there is a spotlight. If I change it to sphere, see what 3ds Max does. It makes a sphere of light, but it automatically changes the distribution to uniform spherical. Okay? So the combination sphere and spotlight are not compatible. Is a combination that try to connect not compatible elements, so 3ds Max will simply refuse to use it. And you can also see that if you use sphere as shape, look, it happens also that from the distribution menu, look, spotlight is gone and uniform diffuse is gone also. So what if I want to make, let's say, an LED strip? What is an LED strip? An LED strip is nothing else than a very thin but long rectangle of light that emits light in one side only, so I have to use the combination that is rectangle as a shape and uniform diffuse as distribution. Let's see if it works. Rectangle. Let's see if I make rectangle, what happens? It happens that, boom, my uniform diffuse becomes available again. So I can have this combination. So not all combinations are possible, just those that I have written before. And if I want to make an LED strip, the only thing that I have to do is I will make the size of my rectangle, let's say, as long as the LED strip, but for example it would be like 1 centimeter or slightly less. It would be like that. Okay? And this would be my LED strip simulation that is longer, okay? It is not more uniform because it also manages the shape. I can make it super long. Okay? Of course, an LED won't be as bright as 6,000 lumens. Like that. And this will be the effect of simulating an LED strip that has a certain distribution and a certain shape with certain size. Okay? Makes sense? Thanks! A lot. For example, you know in reality, when you can simulate a sphere that is, look, we'll place it here, a sphere that would be like 30 centimeters of radius, and that makes these very, very, look how soft shadows are with a spherical big light. For example, you can achieve this effect if you use a bulb lamp, so a uniform spherical light, in combination with a device like this. Have you ever seen this? Now are called IKEA things. When IKEA wasn't existing in Italy, they were here, for example, they were just called like Chinese lanterns, because they are made with a very thin, specific white paper, okay, and they diffuse light. But if you use this kind of light, technically what you have is, you have inside your bulb lamp, that is your uniform diffuse. Outside, this is your sphere shape. You should use dimensions. Here says 45 centimeters. I think this is the diameter. And the effect of light by using this particular solution will be something that is that. It's very soft. It's just a little bit smaller. It is like 23, but it is very soft and diffuse as final result. Okay? Does it work for all? Till now? Tell me something? Yes, no, maybe. Probably is accepted as well. You can start the LED strip is from the top. Sure you can. There is this is very important. Look, in 3ds Max you have also to place lights where they are in reality. You just need to be a little bit precise, and you just need to avoid placing lights inside an object, because if I place these, look, I will place it here, and then it goes inside the box that is my table. Look. It happens something weird. Now my light is inside the box and it looks like it is emitting light. Then I will make rendering and this will be black. So you just need to be so nice, and your light must be at least 1 millimeter, 0.5 millimeters detached from any object. Then you can place it wherever you need. For example, if I want to make the LED strip underneath the table, like those cool looking furniture, I will make it uniform diffuse and also rectangular. For sure, it has to be as long as the table is. Sorry, it is this one. Okay. Perfect. I will make it, I don't know, with a color, like this. And this will be my LED strip. If I have it on the ceiling, no problems. I will make another one. Let's say Shift and Move, copy, and I will make an LED strip. Let me just see where are my objects. Wait a second. I will answer to all of your all of your questions in a second. Let me one by one. So let's say this is here. Let's say I will make it green. Make it brighter. And I will also place it, let's say, here. But I will make it longer because it is as long as the entire wall. And you will see that it will acquire this longer shape. Fantastic. Okay? So yes, you can place your lights wherever they are and you can give them the shape that you want. Then, let's see second question. So when you would make, for example, said lamp, how do you get the shape without blocking the light? Wait a second, it's not the video that is frozen, it was me that I was frozen. So, yes, a lampshade, like the name says, let me tell you, is a lampshade is an object that is meant to block the light in order to give a certain effect. What it means? Now, I mean, if we were at school, I can show you a school light. But if you see at school, there are lamps that are like this. Look, tube light for office ceiling. Let's say there are lights that are more or less like these at school, okay? And we have tube lamps. Then there is this entire light shade mechanism built on top of that. So again, without guessing, what you need to see is this. First of all, there are tube lights. So I have to make, in 3ds Max, I have to make a light. I have to set uniform spherical and the shape is a cylinder. Okay, it's a very thin cylinder. There are 4 of these, and I will make 4 instants. But all around these objects, there is a certain light fixture. So there is a box, and then this box has elements that are blocking light from sides. So it is, I will quickly do it by making a rectangle and by making it renderable. Exactly. So I make these as a group, and this is exactly like this particular light will work. So I'm not guessing anything, but this particular office light made by having a certain diffuser and a certain amount of light, it will give me this extremely uniform kind of light, simply because I have made the lamp light shade plus my light sources exactly as they are in reality. Okay? Does it make sense? This is the question for Frederick. Does it make sense? Or you can do another thing. You need to be too cool. Look. You make a tube, but wait, you have to look at this. You make a star, but I want my star with 5 points, and I will extrude it. Yes! Just smaller. Okay, look at that. I rotate this star and place it here. And then I will use Shift and Rotate. And I will make these instances. Then I select all of them. And I shift and move them up. And I also rotate them. And then I select all of them again, and I make shift and move. Ready for this? Because this will be unbelievable. Select my tube, go to compound, proboolean, subtraction, start picking, and I will pick all these extruded stars so that I will create these holes. Okay, now check this. I put my tube lamp, sorry, I just need a very simple bulb lamp, not as bright, but I will use this as a light shade, so my lamp is inside this tube with these holes. Okay, where is my light? My light is here. Perfect. And see the magic. I have all my stars projected to the wall. And one day you can also rotate these. And you will see your bedroom becoming a wonderful place. There are only unicorns missing. Okay? And because light has a certain shape also, when I leave for a second for this max working, my stars will be also slightly blurred. Okay? Fantastic, isn't it? So, let's answer to last question. That is, what about wall lighting panels? This is a little bit more complex because this involves instead a material parameter that is called emission. So look, and this will be last thing for today. Basically, if we have light wall, what happens is that, let's say this is a wall panel that is emitting light, but these kind of elements are making such a diffuse light that their light is basically like they are simply self-illuminating, and they are more or less, they are glowing rather than projecting a strong amount of light. So to make panels like these, we have instead to work with material. I will make a new physical material. I will apply this to my wall panel. And in my physical material, the only parameter, I mean, I can do whatever I want. I can make it white or another color in here. It doesn't really change anything, because the thing that I want to show you is this parameter called emission. Emission basically makes an object becoming self-illuminated. And you have, first of all, to set that is emitting, so this from 0 should be higher. And you will see that immediately into the preview, your panel will start being bright, even if there is not that much light. This field, this number basically sets how bright this will be. And this is a little bit complex. You should make a few tries, but we can try 25 for a room like this. This should be fine. This instead is the color that it is emitting. So for now I will keep it white. But unfortunately, light emitted from a material is something that I can see only when I click rendering button. So to check if this object has really like an halo of light all around it. So I have to set just emission on a material, and then I have to click render. And if everything is right, maybe it is a little too much, because you can see that the entire thing is a little bit whitish, but you can see that this element is self-illuminating. It is emitting this glowing light. Okay, and this is how to make elements that are self-illuminated. You can push this technique even more. For example, I can do this. Look. With the same technique, I can make a line. Let's say I will start making this line like this, and I will make it renderable, but I will make it radial so that it has a round section, and also only for aesthetic purpose I will make all these vertices smooth. And see this, because this would be insane. Let's say I rotate these and I place this, let's say, on this wall. Slightly detach it even. And I will use a similar material. I will just do it again, just to show you. So I make a physical material. I double click on it so that I will change this one. I change emission, so I enable it by putting this value to 1. Let's say here I would like to have a red color instead of white, and I will set luminance to 25. So then I apply this to my three-dimensional line, and it will look like this. But if I render, it should look a lot, no, can be more. So wait a second, it has to be beautiful. So I will just make it, first of all, a little bit thicker. Exactly. and then maybe even more than 25. I will make it 50. But if I render, it will work like a self-illuminating glowing object, basically like a neon sign, for example, or like you asked, like a wall panel element that is self-illuminating. Okay? Was this what you were asking? Sorry, in the meantime, I probably was able to find this horrible mosquito. Yes, when I render, due to the fact that rendering and streaming are both using the resource of my computer, when it renders, it can't stream. Okay? So I'm so sorry, but I mean, this is rendering and streaming in real time will require two computers, so one making the streaming, one making the rendering, and I have not. At least I have this beautiful computer. I mean, if you see my streaming, you know what? Tomorrow I will probably make a small video to show you how is my streaming setup, and I want to do it just to make, just to have fun, but I need just to make it a little bit better, and I will post it somewhere, so you have to check it because it is amazing. Okay, so this is it for today, and if as usual, if you have questions, write me, send me file, whatever. But for today, it's okay to change my plan right. Define what it means, my plan right, a lot. I mean, what does this question mean? Because, I mean, you want to change your AutoCAD project, you can slightly change if this is the question, especially if now that you have more experience. Yes, because you have more experience than last semester, if you find mistakes, of course you can change them. So if you see that staircase were just facing the wall or clearly visible mistakes, you can change them, but not, I mean, when you present your final project, you may start from your original AutoCAD, so it's not that your original AutoCAD was a square and then your rendering is a circular house. You can fix it, but not changing completely, absolutely not. It has to be like you have that floor plan, that project, and you have to turn it into a 3ds Max. If not, it would be just a free homework. No, you can't change it completely, absolutely not. Also because, imagine, maybe you have made a wonderful, complex AutoCAD final project, and then for 3ds Max you make just an empty room. Come on. No. Thank you too. You ruined my final sentence when I have to say fun, not too much, but it's okay. Okay, so for today, this is enough. And as usual, like your classmate said, have fun, not too much. And we will see next week, Wednesday. Okay? Bye, everyone. It has been a pleasure. So let's stop it from here.